Question 10, 2019, Part A. A particle P moves along a straight line. The speed of P at time t is v, where v equals at squared plus bt plus c. And a, b and c are all constants. The initial speed of the particle is 15. After 2.5 seconds, the particle reaches its minimum speed of 2.5 meters per second. In part 1, we want to try and find the value of a, b and c. So here we know that v equals at squared plus bt plus c. Now we're told that the initial speed of the particle is 15. So that means when t equals 0, v equals 15. If we substitute in v is 15 and t is 0, 15 then equals a times 0 to b squared plus b times 0 plus c. So this just means then c equals 15. This means then that v can be written as at squared plus bt plus 15. We now know the c value is 15. Next of all then, we know that the speed is 2.5 when the time is 2.5. So when the time is 2.5 seconds, the speed v is 2.5 meters per second. So we substitute in v is 2.5 and t is 2.5. Now here we can divide everything by 2.5 and you get 1 equals 2.5 plus b plus 6. And if you bring the 6 across, 1 minus 6 is a minus 5. So this means 2.5a plus b equals a minus 5. So we can label that then as equation number 1. So again we had v was at squared plus bt plus 15. Now we were told that the speed was a minimum after 2.5 seconds. To get a minimum you have to differentiate and equate it to 0. Now if you differentiate v equals at squared plus bt plus 15, the vdt just equals 2at plus b. Now we're going to put in t is 2.5 and we're going to let the vdt equal 0. So this means 0 equals 2a times 2.5 plus b. Now 2a by 2.5 is a 5a and a plus b. Now if we bring everything from the right over to the left then, this means minus 5a minus b equals 0. So we can label that as equation number 2. So we're after formulating two equations with two unknowns and we're now going to solve these simultaneously. So equation number 1, we had 2.5a plus b equals a minus 5. Equation number 2 then, we've got a minus 5a minus b equals 0. The b's cancel out, and if we add the a's you get minus 2.5a and the constants give a minus 5. This means the a value equals 2. To find the b value, we can substitute that value for a into equation 1 or equation number 2. Now I've used equation number 1 and this gives 2.5 by 2 plus b equals a minus 5. And this means then b equals minus 10. So we found a value for a, b and c. So this means we now have the equation for the velocity v. So v can be written as now 2t squared minus 10t plus 15. Now in part 2 then we want to find the acceleration of p when the time is 4 seconds. So acceleration is the vdt. It's the rate of change of velocity with respect to time. So if we differentiate, the vdt is going to give 4t minus 10. If we put in then t is 4, this gives 4 times 4 minus 10, and this gives 16 minus 10, so the acceleration is 6. Part 3 then, we want to find the distance travelled by p in the third second of the motion. Now we know what velocity is, but velocity by definition is the SDT. It's the rate of change of displacement with respect to time. So the SDT is 2t squared minus 10t plus 15. Now if we bring the dt across and multiply, and then if we integrate both sides, and we're going to use the following limits. So we're looking for the distance travelled in the third second of motion. So that means the time goes between 2 and 3 seconds, and we want to find the distance travelled in that. So after 2 seconds, the distance is 0, and we're looking for the distance travelled then in the third second. That's when time goes between 2 and 3 seconds. Now if we integrate then the right hand side, this gives 2t cubed over 3 minus 5t squared plus 15t, and then the limits go from 2 to 3. If you integrate the s, you just get s, and the limits go from 0 to s. So on the left hand side you just get s, and then if you put in 3 first of all, and then minus, and then put in the lower limit, put in 2 for t. And then using a calculator, this gives s as 16 over 3 meters.